Hi, I'm Josh Crow,
And I'm Himai Durrani.
and we are doing the effect of wing configuration on variable speeds. At the end of last year, we were both left without a project, so this year we conversed about our shared love of aerodynamics. We read some articles on the testing of wings and concluded that a project dealing with wing performance at supersonic speeds would be the best option. With some more online research and consultation of our mentor, Dr. David E. Crow Sr., we were able to come up with a comprehensive study of wing shape at variable.
This project is a collaboration between the two of us and the former Vice President of Pratt & Whitney, Dr. David E. Crow Sr. He will be responsible for teaching us the aerodynamic equations for lift and drag, as well as walking us through solving the equations. Josh will deal with the calculations and data interpretation, while I handle the 3D modeling and literature.
The wing configuration of an aircraft plays a vital role in how the plane moves through the air, and having certain designs at certain speeds can result in the aircraft being inefficient and unsafe. Planes with wings designed for subsonic and transonic flight are not capable of operating at higher speeds safely or efficiently. Similarly, planes that have wings designed to handle supersonic and hypersonic speeds cannot operate at slower speeds effectively. Therefore, it is proposed to study which configuration of the wing will operate best at all speeds. It is hypothesized that an Ogaiva delta wing will perform best at high speeds and perform all right at slower ones.
The first step is to research which wing perform most efficiently at each of the 4 speeds, using both information from previous studies and Dr. David E. Crow's knowledge of aircraft. This basis of efficiency will be determined by the lift coefficient corresponding with the wing configuration. After this data is collected, it will be put into graphs and tables to show which wing and tail wing performs the best at each speed. After the best wing for each speed is discovered, the dimensions and aspect ratios for each type of wing will be researched and found utilizing the other studies such as the Concord Project, NASA research on lift coefficients, and the University of Kansas Aeronautical Engineering research on incidence angles, and the Project Mentor. When all this data is collected, it will be plugged into equations to calculate the effectiveness of each form of wing at each speed. 3D design software will then be used to illustrate the different types of wings. The equations will incorporate applicable forces to apply to each wing, such as friction and gravity. Factors such as air density, air composition, and altitude will be kept constant. In finality, the results of this project will yield which wing configuration will be the most efficient at all speeds. Conclusions can then be drawn as to how and why certain wing constructions function so well. Thank you for your time to watch our video.